All right, so we have two examples here. All right, we've got the probability mass function. All right, 1 over 6x, the value for the random variables where x equals 1, 2, or 3. Right, show that this is a probability mass function. So we start with number one. Right, so the way we show that it's a probability mass function. All right, to show that it's a probability mass function, the summation of the probabilities must equal to 1. All right. Summation of probabilities must equal to 1. So let's make a probability distribution, discrete probability distribution. All right. For this. All right. So here we have our random variable. It's a random variable because it can take any values in an experiment. Then we have our probabilities here. All right. So for 1, 2, and 3, let's just solve it on the side. We've been given 1 over 6x. So we're going to, for x equals 1, the probability, we're going to substitute this x in this equation here to get our value. When x equals 2, we also substitute x for 2. When x equals 3, substitute x for 3. All right, so let me just do the workings on the side. So 1 over 6 times 1 when x equals 1. When x equals 1, the probability is 1 over 6. So here on our table, probability here is 1 over 6. All right. When x equals 2, when x equals 2, I'm going to put here 1 over 6. We substitute with 2 here, which equals 2 over 6. All right. We can simplify this fraction, but for now, let's not simplify it because we want to show that this is a probability mass function that it equals to 1. All right. Then when x equals 3, so we have 1 over 6, and then we have 3 here, 3 over 6. All right. So if you add 1 over 6 plus 2 over 6 plus 3 over 6, all right, common denominator is 6 here. 1 plus 2 plus 3, that is 6. 6 divided by 6 is 1. So we have shown that it is a probability mass function because it suits this condition, right? The summation of the probabilities must equal 1. So in case they ever ask you that, just know they want you to show that the summation of the probabilities is equal to 1. All right, we go to the second question. All right, we have another probability mass function here given. All right, find the value of k. All right, so also here to find the value of k, we'll need to make a discrete probability distribution. All right. So I'm going to put here otherwise. All right, meaning any values which are not in this range 1 to 3, the probability is 0. All right, the probability is 0. Okay, so I have here x for a random variable, then the probability associated with it. Right, so we've got 1, 2, and 3. Okay, so we also have to solve on the other side. So when x equals 1, we put it in this here, this formula here, k, open brackets 5x plus 2. So we're going to have k 5, let's substitute the 1 with 5 plus 2. 5 times 1 is 5. 5 plus 2 is 7. 7 times k, 7k. When x equals 2, all right, 5 times 2, 10. 10 plus 2, 12. All right, when x equals 3,
15 plus 2, so
15 plus 2, that's 17k. All right, so remember, summation of the probabilities equals 1.
yes.
Right, so we're going to have 7k, summation of probabilities equals 1. So we have 7k plus 12k plus 17k equals 1. So what is 7 plus 12 is 19. 19 plus 17?
19 plus 17 is 36.
36k. All right, so we divide both sides by 36. K equals 1 over 36. Yes, so we can clean up our probability distribution here. All right, so here we have 7 divided by 36, 12 divided by 36. Right, so here we rewrite here 7 divided by 36, and here also 12 divided by 36. All right, because we're substituting this k with 1 over 36, right?
Yes.
And then have 17 over 36, right? If you add this 7 over 36 plus 12 over 36 plus 17 over 36, you're going to get 36 over 36, which you get 1. Right? You can get 1. Okay? Yes.